Hello everyone. So finally decided to put my best foot forward to make this video. Yeah, it's been a long time in the making, a couple of months now I think. So yeah. Anyway, I guess what we're trying to do today, the topic of today, if you can't guess by the command on the screen there, is permissions in Linux. Permissions and ownership specifically. So the scope of the video basically is going to be basic Linux permissions. So basically, you know, the ones probably most people are familiar with. You know, the octal set. So 777, for instance. But also, I'm going to cover the special permissions. You know, like sticky bit and stuff like that. Stuff probably some people probably don't even know exist. But maybe more. Some of the more advanced Linux users might know that they exist, but maybe not what they do. So I'm going to try to cover that and maybe give a couple examples to the best of my ability. And also ownership and things of that nature. I was thinking about trying to cover access control lists in this video too, but I'm actually going to scope that into another video later on. As with most of my videos, this is going to be kind of a deep dive. So, you know, I'm going to try to be as thorough as possible and teach you as much as possible about the topic at hand. But, you know, for the very advanced Linux user who knows all this stuff already, you know, I don't know. Hopefully you'll come away with something, you know, if you actually watch it to the end, hopefully you'll come away with some, you know, newfound information. But you know, the nature of the context here is, well, fairly basic if you're, you know, just looking at it from a textbook standard. This is, you know, this is kind of one of the first things you should probably be learning about if you're just starting out to learn Linux, is the gist of the file system permissions, because it's pretty important to understand it. Having said that, though, I do have a sort of catalyst for making this video. And that is, I've seen the command on screen used very, very, very often, far too often. And I don't know if you're aware of this, but if you're using this command, you're probably wrong, like almost always. I actually can't think of an example where I would agree with your utilization of that command. And the ... Obviously is a placeholder represented whatever you put after this. It's wrong. If you are putting chmod 777 into your terminal, you should stop and rethink what you're doing, because you're probably doing it wrong. I've seen this used as a knee-jerk reaction. So a lot of times people will install something and it won't work for whatever reason, and it can't possibly be a misconfiguration. It's got to be permissions. It always is. You know, everybody defaults to that. And so what do? They go in and they chmod 777, and, you know, then they've effectively, quote-unquote, ruled out permissions. But the problem with doing that is the permissions almost never end up going back to what they should be. They stay at 777, which is highly dangerous. It should never generally be there in the first place. If you have your ownership correct, then your permission should be right, technically speaking. And generally speaking, if you're installing a package, like from the package manager, your permission should generally come down correct from the package. You should not need to modify permissions on things. It's pretty rare you actually have to mess with them. So before we get into the meat and potatoes of the video, I'm going to give you some warnings and some, you know, tips, safety tips and things when dealing with permissions and general file system stuff, and, you know, just basic file system stuff. And so the first thing we're going to talk about is you know, haphazardly modifying permissions. So haphazardly and carelessly modifying your file and folder permissions pretty much anywhere on your file system can lead to disaster, especially if you do it recursively. And we're going to talk about that in a minute. It's dangerous, and it can break your system if you use it carelessly, or if you don't know what you're doing. Or it could even introduce security vulnerabilities. It can cause your system to not boot up. Or you could lose your ability to SSH into things, depending on what and where you've, you know, chmodded or chowned something. So generally speaking, I would argue that you should never use the chmod or chown commands unless you know very specifically and exactly what you are doing and why. Because doing it incorrectly can cause trouble. and it's kind of hard to work out sometimes where you've made these alterations to your system, and it's hard to figure out how to put these things back, especially if you do it recursively. And so getting into the recursive thing, if you add a -r to this, you add a -r to this anywhere, either at the beginning before the 777 or after. You can do it in either place. You might see it like this. That makes it recursive, meaning it will apply to whatever directory you're in and everything below it. And that is especially dangerous. And I would strongly advise you to never do this unless you know exactly what you are about to be doing. Because recursively doing this command on your file system can absolutely destroy your computer if you do it wrong. And I will give you some examples of why. Let's say, and this is a virtual machine, so if I mess up here, it's not going to break my heart. I could just restore from a snapshot. But let's say I wanted to chmod, or chmod 777 a particular directory in my home directory, and so I'm going to do something like I don't know, documents, right? Documents, DOCU, right? And then I want to do, like, say, files or whatever might be in there. And you might be tempted to do that. So files is a directory, and you want to chmod everything in it. You might be tempted to put that final / at the end. I would argue don't do that. It's unnecessary, and if you accidentally do this, well, you've just toasted your entire system. Because the way Linux commands work, it will view that, due to the space there, as two different arguments to the command. And so basically it will chmod everything from documents files recursively down, but it will also chmod everything from / recursively down. And I don't know if you know this, but that's the root of your file system tree, which means everything on your computer. So yeah, be careful with that / at the end there. Don't leave dangling / It's generally a bad idea. Don't recursive unless you're absolutely certain you need to and you know exactly what you're going to touch. And don't modify permissions on your file or folder unless you know you need to, and you're sure that's what you need to do, because more likely than not, you're causing more problems than you're solving. But more than any of that, do not use 777. Just don't do it. It's almost always wrong. Almost always. There are very few. I can't even, like I said before, I can't even think of a reason you would want to do it. That's legitimate. Between normal understanding of the file system permissions and ownership, and then once you accompany that with access control lists, you have everything you need to be able to secure your file system and not use this chmod 777 command. You just don't need to. And so, yeah, I would highly advise you to avoid it. And I have seen everyone do it. I watched a cybersecurity person who claimed they were an expert, and they probably are. They probably know very well what they're doing. But they wanted to make a file executable, and then they used this 777 command to do that, which will work. It'll make it executable, but you can't be a cybersecurity expert and use this command, right? Those are mutually exclusive ideas. Don't do that, okay? So this video is to show you all of the things that the file system permissions are doing, how they work, how to read them, how to understand them, so that hopefully you will not make this very critical mistake, because making it can, in fact, be catastrophic, especially if you're trying to secure something, because this is the opposite of security. So let's look at 777. What does that actually mean? Okay, so to understand that, we need to break down what the permissions actually look like on your file system. So let's give ourselves a little ls-al, or you could do ll if you're on a system that actually supports that alias, or if you have that alias in place. I'll do al because it's more distro agnostic. And you'll notice that we have some interesting output here. So what does this output all mean? Let's break it down a little bit, okay? So of course we have the obvious over here. This is your file, right? that is in the directory. This blue guy here is a subdirectory, so it's another directory below the one that I'm in. This is the parent directory, and this is the current directory. So dot dot is a directory above, and dot is always the directory you're in. So that's your directory. So this would be the permissions on the directory I'm in. Okay. The green here generally means that that your file is executable, but if your terminal doesn't have colors or whatever, you can probably ignore the greens and the blues. You know, in my case, the blue stuff means that it's a directory. Green stuff means that it's an executable file. So just be aware. But in your case, you may not have colors depending on how your terminal is set up and configured. Over here we have the time that the file was modified. I believe that's modification. And then this is the size of the file. So these are obviously blank files that are here just for testing purposes. I think I just touched them so that they would be, you know, just files to demonstrate with. And this is a nested directory, so it has some size to it. So these two here, these are ownership. So this is the user owner, the user that owns the file or folder. And then this would be the group that owns the file or folder. Okay. This is the number of hard links available to that particular directory. Hard links are a bit outside of the scope of this particular video. I've talked about it a little bit in the past, but yeah. So these are hard links. So there's one hard link to these guys. Directories are a little bit different, I think, but generally, yeah, that's the number of hard links to that particular file. And then this over here is your permissions. So this guy, this plus, that means you have an access control list attached to that object, right? So if you see that plus there. Now, if you're using one of those special fancy newfangled, God, I sound old, Rust applications that people have rewritten to do this, I think Exa is one, it may not support showing this plus sign, which is why I don't tend to like those. Because I like to know if there's an access control list attached to my thing, and I like my ls command to show me that. So yeah, just be aware that if you're using one of those, you might not get this output. You'll get fancy icons and stuff, but you won't get what's important, which is the complete picture of what your permissions actually look like. So I think there is LSA, I want to say, is the one that I use, and it does actually show the plus, and it shows, if you do the tech, I think Z, you'll get SE Linux output. SE Linux is obviously outside the scope of this video too, but yeah, some of those don't actually show that, so just be aware. And then this is your actual permission structure. We're going to skip that for just a second, and we're going to talk about this leading D and this leading dash here. So the D is for directory, okay, and the dash, or hyphen, or tac, whatever you want to say, it is an indication that that is just a standard normal file, nothing special about it, okay? So a dash will always be a normal file, all right? And then a D will be a directory, an L would be a symlink, and if you're asking what does a hard link look like, that's a hard link. That's what all files on your system are hard links. Anyway. So, unless they're another kind of special type of file, right? But yes, all normal files are technically hard links. Okay, so let's talk about the permissions. So these are the actual indications of the normal file system privileges on your computer, okay? So the first set, because these are in sets of threes, this is the user's set of permissions, right? So this is the owner of the file. So in this case, it would be Joe, right? So if we look at test 2 here, right? Let's look at test 2, okay? So Joe owns test 2, that would be me, right? And you can see I have an R and a W and a dash, right? R is for read, W is for write, and the dash means we're missing the permission. That permission would normally be an X if I had it, and that would be execute. That's the execute permission, okay? Now you can see I can probably execute this file because as the group owner, I do have execute privileges to this file. But I don't have write permissions to the file as the group owner. But I'm pretty sure I'll be able to write or execute that file, hence it being green. But the everyone group here, right, has no permissions. So the group in the middle, RWX or R-X in this case, this is for the group. So the Joe group, people who are joined to the Joe group could then read or execute this file. And then the last three dashes, as I indicated before, are the everyone permission, right? And that is why 777 is so catastrophically bad and insecure, because 777 basically means that you have full permissions: read, write X, read, write X, read, write X. And read, write X on all of those means that everyone on the system, no matter what they are, can read the file, can write to the file, and can execute the file as though it's a program on the computer. That is very, very bad, okay? One other thing to note is that 777 and 077 and 007, though you may think they are identical, they are not identical, and they will prevent the owner from actually, so 007, for instance, would mean everyone but the owner of the file can read, write, and execute to that particular file. And so, yeah, you should understand that if you put a 0 for owner and a 0 for group, then the owner and the group owner are basically locked out of the file. Root ignores all permissions and can do anything it wants with a file, generally speaking. So just also be aware of that. You can set a file to 000 and root can still do whatever it wants to it. The only way to prevent root from doing something to a file is to use something like SE Linux or AppArmor to lock the file down further. Or I think you can also use noexec, and you can also make the file immutable, which is read-only, in which case the root user will not be able to write to the file. They will still be able to execute the file or read the file, but they could not write to it. However, the root user can remove the immutability flag, and then you will be able to do it again. That is useful, and I will talk about it a little bit later. It's probably the only one of the very special flags I'm really going to deep dive into, because it's the one that I use more than any other one. So it's the one I know the most about offhand, but I will show you. I will show you how to work those commands as well, and how to recognize whether or not they're in effect. So that's the breakdown of what permissions look like. So when you're talking about RWX like that, RWX, that is what we call the symbolic representation, okay, or the symbolic notation of the file permissions, right? There is another way to view and understand file permissions, and that is with what we call the octal or numeric representation. And it's usually called the octal representation of the file, file system permissions. And so what does that mean? Well, you have the numbers 1, and then you have 2, and then you have 4, okay? And all three of those numbers together, if you add them up, they're going to sum up to the number 7. And that should look pretty familiar, because the permission is 777, right? That means full permissions. So we're going to rearrange these a little bit, because I'll make it easier for you to understand here this way, right? 4, 2, and 1, okay? Why did I do it that way? Well, read, write, X, okay? Read is 4, write is 2, execute is 1. So one way to determine if your file system or if your file is going to be executable is to understand that it has an odd permission category, right? So if the permission is a 5 or a 7 or a 1, it's executable, right? Because it's the only mathematical way for it to reach an odd number is for that 1 to be present, right? Otherwise, you'll always come up with an even number, either 0, a 6, a 4, a 2, something to that effect, right? And so basically you're doing addition. So if I wanted to give a file read and write privileges but not execute, I would give it a 6, 4 and 2 together, right? If I wanted the file to have write and execute, or read and execute but not write, I would give it a 5, right? Because 4 and 1 make 5. And then The other 7s would be for the group and the everyone. So user, group, everyone, read write x, right? So that is basically the gist of how it is done. So how would I modify the permissions on this test2? Let's say I wanted to give test2's user execute privileges. I could do this 2 different ways. I could say I want to modify it this way, chmod, right? And then I could do, if I wanted to give it x, it's already got read and write, so let's assume we're going to add x. I could do 7, and then I would do 5 and then 0. And that would be read write x for the user, read and execute for the group, and then no permissions for everyone else, right? And then I could do test2.text, okay? And if I press enter, and we do ls tac l test2.text, you can see here that I have altered the permissions for that particular file such that I now have the execute privilege there, okay? So the other way I could do that is with the symbolic representation. So I could also do something like chmod, and then I could do u plus x, and that would give the user execute privileges to that particular file. Now, if I wanted to remove the execute privileges, I could either use the numeric thing and I could go back to 650, or I could do u minus x, right? And let's see if that works. So if I ls tac l, you can see that I have lost the execute privilege there, right? I could also modify more than one thing. So if I wanted to take away the execute privilege there, but I also, well, that's actually, let's add it back so you can see the difference. So if I add execute privileges, I can add a comma, and then I could do g plus w, and then I could even do o plus, and then I could do rw if I wanted to add read write to everyone, right? Now this is almost the dangerous 777 command. This is probably not recommended either for most files, but if I look at this, right, you can see that I've given myself basically 776, which is still not a great permission level to have, right? Generally, you want everyone to have no permissions or read permissions. Generally not write or execute. Most definitely not execute. There are some differences to this. There are some exceptions, and I'll cover them later. But for basic files, read, write, execute is what you want. You don't want a 7 in that last column. You don't even want a 6 in that last column. The most you probably want is a 4. Because everyone on the system being able to write to a file or execute the file is probably bad security practice. You know, and it's especially true because a lot of times I see that going on in like Apache directories, you know, web server stuff, and that is not okay. Because that's just a huge security vulnerability. If somebody compromises your Apache server, they could use that to exploit the system, and you don't want that. So be careful with your permissions. That's going to be the running theme of this video. All right, so moving on. So that is basically one way that you can alter those permissions. So let's move on and talk a bit more about, well, let's talk about changing ownership. So ownership you would change with chown, right? So let's do chown. And then you could do test, I think, as a user, and we could do test2.text, okay? Oh, yeah, I might have to actually use sudo for that one. And then if I look, you can see now that the test user has ownership over that. There's also the chgrp command. So I could do chgrp if I wanted to change the group of that particular file. So if I wanted to change it to the test group, that would work. The other thing I could do is I could use the chown command, and I could do test : or even test dot. Test : works as well, like that, right? And that would give it the test user and the test group. So if I did that, you could see now that we have test up here for our test2 file, okay, like that. So I can do that, and of course I can change it back by doing Joe. So to show you that works as well, there you go. Okay, so let's talk a bit about different situations for your file system permissions, because we need to discuss directories, and we also need to discuss basically symlinks, because they are exceptions to the rules. So how so? All right, so let's look at a directory. So this test.nest or test nest directory here, it's kind of a weird way to name that. But anyway, this particular directory here, you can see we have read write x, we have read x, and then we have no permissions, okay? So the important thing you need to understand with a directory is that when you open a directory, you are executing that directory as if it is a program, effectively, right? So if I cd into test nest there, right, I have executed that directory. That is effectively what I have done, okay? And I can actually prove this because I can actually do this, right? And that, if you don't know, is how you execute a script. You put a // and then whatever .shell at the end, and you'll notice that if I do that, what happens? I go into the directory. That's what happened. I just executed it. That is, in fact, another way to change directories without using the cd command, is to simply execute it as though it is an executable script on your system, because effectively it is. So if you execute the directory, you'll enter the directory. So what does that mean? Well, it means if you take the execute privilege away from a directory, so if I do this, right, and if I do chmod -x test next, right, or nest or whatever, and then we check the permissions, we should not have execute. Now if I try to cd into test nest, you'll see I get permission denied. So you cannot enter that directory unless you have execute privileges. So if you want any user on your system to be able to enter the directory, they will need a minimum of execute privileges on the directory. And then to list the contents, they'll probably need the read permission, right? So for instance, if I take the read permission away, but I add x, let's try that out. Let's see what happens. So let's do chmod, right? And we'll do +x, and we'll do -r, right? Like that, and then test, right? Like that, okay? Let's see what the permissions look like. Yes, so we have -r in that file. So here we go. We just have execute, and of course we have write here. But if I cd into test, right, nest, and I ls, I don't have permission to read. So I can't actually view what's in the directory, but I can still get to it. So if you want somebody to be able to see the contents of the directory, and you want them to be able to get into the directory, they needed a minimum of 5 for the permissions, because they need read and they need execute in order to see and read the directory. Now, if you want to make a Dropbox style directory where a person can, for instance, put files in the directory, but they can't actually see what's in there, you can give it a 3, right, which would be write and execute. They need to be able to execute the directory to enter it, to be able to drop files, and then they'll need write to be able to drop the file. But they will not be able to list the contents of the directory. Now, you'll notice here that I have a write and an x. So I technically can write to this directory right now. So if I touch test file drop.txt, you can see that that works, right? But if I ls, no dice, okay? So let's do a chmod and give myself a +r. We'll do u+r on the directory we're in, right? So now if I ls, I should be able to see the file that I created. There it is. So that is how directory privileges work. Now, on your file system, if you do this command, I definitely showed off the find command in a prior video, so you may, if you watch that video, recognize this. You can do, I think it's perm 777, I want to say. And then let's actually do chmod. We're going to do the dreaded command so I can test this out, okay? So if I do find perm 777, I want to say it's perm. I gotta remember if it is or not. Yes, it is. So, so that will show you any file on your system with that particular permission type or permission level. So that is a way where you can check on your file system if you have files with that permission. Interestingly, if you do that from your root directory, you're going to get a lot of files back, even if you're on a system that you have never touched before. You've never done anything. You just installed it by default. That's it. You will get a specific file that has that permission. A whole bunch of them, in fact. So what am I talking about? Well, the file you're going to get back is a Simlink. What is a Simlink? Well, let's make one real quick. So if I do ln-s, right? And actually, let me prove the point by first doing a chmod and put this back to a reasonable permission of 6, maybe 4 test file, right? So that is read, write, read, read. Okay, so everybody can read the file, but only the owner can actually modify it. That's a sane level of permission. So let's now make a Simlink to it. So if I do an ln-s and we make our test file drop, I think it's like that, right? Yep. Okay, so you'll see here that file has full permission, 777. Okay, that is a rule of thumb. Every Simlink is going to look like that no matter what. So if you see tons of Simlinks like that, that's perfectly fine and absolutely normal. What happens if I try to change that on the Simlink, I wonder? Well, let's do that. Let's find out. Okay, let's add a dot link here. The dot link is arbitrary, by the way. It does not have to have that at the end. Okay, let's look at the permissions on the file. Ta-da! Nothing happened. Nothing at all. Let's actually do this. Let's see. Let's see if we can remove that. Now, what happened? Well, did you catch it? There's a reason why I did the second one. The first one, nothing appeared to have happened because it was the same permission level as the original file had. But you'll notice if I chmod the link, what changed? Well, the original file's permissions changed. And that is something to be very wary of. If you chmod a Simlink, the permissions on the file that change are those of the original file. And the permissions that apply are also those of the original file. So, even though the Simlink says it has 777 privileges, okay, only the owner right now could read or write that file, and only the group owner can read the file, and nobody else can do anything to it. Okay? So that's something to understand. If you chmod your link, it will point that mod back to the original file. Your link will not change. It's going to continue to say 777 forever, because that's how they work. But the target original file will get updated with the new permission level. Something to keep in mind. Okay. So now that we've covered that, we can also, so if you want to really get an idea, this is a little bit outside of the scope of the video, but if you want to get an idea of legitimately if you have problem files on your system that have wrong permission levels, you could use this command, find perm 777, and then you can do a tac not, or just a bang even, and then you can do tac type and then L, and that will rule out any file that does not have the type Simlink on it, right? So if I remove this, you'll notice that it will return the Simlink, right? But if I add this, it will not return the Simlink. If I chmod 777, our test file again, right, and then I do this command, you'll notice it returns the test file. So the bang basically is invert. So it's saying don't find files that have whatever follows this thing. And in this case, I'm doing type L. So watch my find video for that for more information on finding files. But if you want to audit your system to see if somebody before you has done not so great things to it with the file permissions, that is a way to both find them and with the exec command fix it. So yeah, find video will have all that information for you in there. I won't recover it here. The next thing I want to discuss is special permissions. So special permissions, you may not know this, But let's do chmod. There is actually 4 sevens here. Well, 4 digits here, really. And that first digit is a special digit. It's assumed to be not assigned, or it's not really the same as 0, because 0 is basically specifically saying no permissions. And it's not even the best approach to use the octal representation, because I think the octal representation kind of gets janky a little bit when it comes to removing specifically the special permissions. But yeah, it's there. So what do those control? Well, you have another set of 4, 2, and 1. And they are SetUID, or SWID, SetGID, or SGID, or SGID, however you want to pronounce it, SGID. And then there is the sticky bit, okay? And they do different things. All right, so let's start at the top with SetUID. So to SetUID, well, let's talk about what SetUID actually does first. So the SetUID bit is represented by a lowercase s in the owner's execute permission, or position, right? So basically, if I lsattr this, right, you'll see the owner's execute permission here is an X, and these still have very naughty file permissions, but we're going to, well, I don't care, it's just a test file. But anyway, test file on a test VM for demonstration purposes. No, although it is highly bothering me to see that. Still, though. Okay, so the X there, right, it would be a little s if you had the SUID bit set on that, and I'll show you that in just a minute. So the octal representation is 4, and the special permission allows a user to access files and directories that are normally only available to the owner of the file, or whatever. So usually when a user executes a command that accesses files, the system checks the user's permissions for the files, right? So if I execute the file, I'm executing it as me. In some cases, that may cause problems. For example, the PASSWD command makes it possible for a normal user to change passwords by updating a few system files that they normally would not have access to, like etc password and etc shadow, because those can't be accessed by non-root accounts. So that's what the SetUID permission is actually for. For instance, if I were to execute the PASSWD command as me and the SetUID permission was not there, it would execute as though it were using my permissions on the file, and that's not what we want, because then I won't be able to modify etc shadow, which would be horrible if I were able to modify that. That's literally all the login stuff for the system. So you can't use, you don't want normal users to be able to edit that file, but they obviously might want to be able to change their own password. So you have SetUID on the PASSWD command. So if I do where is PASSWD, it's going to be in, yeah, user bin. So if I do ls tag l and then user bin PASSWD, you can see here we have a little s. Note the little s. So that means you have SetUID permissions on or SUID permissions on that particular file, meaning that if I execute that file, it's going to execute as though I am the root user. So it is also possible that you'll see a capital S in that string, and you're going to notice a running theme with these SetUID bit strings, all of these special permissions. A capital letter means that the SetUID bit is there, but the execute bit is not. Okay, so it's like saying you have SUID privileges, but you do not have execute privileges. It's normally weird to see that, because typically speaking, all of these things are going to work with execute stuff. So if you can't execute the file anyway, then SUID really doesn't mean a lot. But if you see the capital S, that's what it means. And I'll show you that on our normal file here. So if I do an lsattr, right? So let's do chmod. Now if I do a 4777, right, that'll update it to the SUID. I'm sorry, I got to put the guy in there. So now if I lsattr it, you'll see that we have an S there, right? See that? Okay, so if I put that back to a 0, let's see what happens. Okay, so you can see that it's taken the permission away. So now if I do a 4 here, right, but then I do a 6 here, effectively taking away execute on the root, on the owner's permissions, right? Of course, it'll still be executable by people in the root or in the user's group or in the or anybody else on the system, but the owner will not be able to execute. You can see here you have a capital S, and so that's what I mean by that, right? That means that the SUID bit is there, but we are not able to execute the file, which means that you can't really do much with it because you can't execute it, and that's the whole point. So yeah. Anyway, that's the gist of the SUID. So there's also another special permission called SGID. And this one's almost just as useful, or this one's very useful, extremely useful, I think. I use this a lot when I do like shared SFTP folders. I find SetGID is very useful there. So let's talk a little bit about what SetGID does after I fix this guy. Back to 0 and then 7. Oh, and I also want to show you, before we move on, let me show you the symbolic representation, and that is going to be U or U plus S, like that. So that will also do it. So if I look now, you'll see I have that. And then, of course, you can also take it away the same way. So if I do U minus S, like this, and then I do the lsattr to see it, you can see it's gone now. So that is also true. And you can also add the commas, so you can comma separate and do more, even more fancy stuff. You could even do U plus, I think you could even do something like this. I don't think I've ever actually tried this, but I'm fairly certain it will work. So if I do something like this, U plus RWX, that should work. It does. Okay, yeah. So that is also safe. So you can get fancier and you can tack these things on. The important thing is to remember SetUID is for the user, SetGID is for the group, so it's going to go in the groups section, and then the sticky bit will actually go in the everyone section, and I'll show you that in a minute. So SetGID is represented as an S in the group's execute permission position. So that will be over here. So basically you'll see the S there instead of in the first column like you do here, right? You'll see it here. Okay, so that will mean that the group has a SetGID bit on it. Again, if it's capital, it means that the SetGID bit is there, but it is not executable, which doesn't make a lot of sense here either, because if you can't execute the directory, well, there's not a whole lot of reason to, you won't be able to get into it. So there's that. But yeah, the SetUID bit or SetGID bit is there under the case of an S in that position. And the octal representation is 2. And it is almost, it's rather similar to SUID, except that the process will have the same group rights of the file being executed. But, and here's the interesting thing, when SGID permission is applied to a directory, all subdirectories and files created inside this directory will get the same group ownership as the main directory and not the user's group ownership. So what does that mean? Well, let's take a look at the directory that I'm sitting in. Okay, you can see here, I'm in this guy here, and this directory is owned by Joe. Let's fix that. Let's set this directory up to be a little bit differently. So we're going to modify the permissions, chmod, and we're going to give the permission 777 on this directory. That's really bad, but we're going to do it anyway, just to prove a point. So let's do that, right? So now everyone can do everything in this directory. Okay, and I did that because I don't want to change users. Let's do an A. There we go. Okay, so now this directory has very bad privileges, right? We've done a bad thing. All right, but here we go. So what I'm going to do now is I'm going to change the ownership of this directory. So chown test:/test, and then dot, and we're going to need to probably sudo that up. Okay, and now here, if I do an lsattr, you can see now the group, the directory is owned by test. But because I have RWX I can still be in this directory, I can still list the directory, and I can still write to the directory, okay? Now, how I would normally handle this if I wasn't being lazy right now and using the naughty 777 command is I would put myself in the group that owns the directory, and then I would just use the group permissions. I would never give everyone on the system full access to a file or folder. That's just silly to do. Instead, I would generally add myself to the group. Now, if, for instance, I had a very complex situation where I had different groups who had different permissions and I wanted them to all have different levels of access to the particular file system or to particular files within the directory, that's where access control lists come in. I would still not 777 the thing. So for everybody going, but what if you've got complex groups? Nope, that's what access control lists are for. And that's what we'd use them for, to do complex things to allow you to have different groups with different levels of access to the same directory, right? That's access control lists. That steps outside of the normal Linux file systems and gets into access control lists. And that is for another video. But just know that it's there, and it's the answer to the question, what if I need X functionality? Ha ha ha, you're wrong, I need to do 777. No, I'm not. Use access control lists are the answer. Anyway, so to move on, let's demonstrate what SGID does now. Okay, so SGID. So let's make a file in here. So let's touch a file. So if I touch a new file, we'll call it new file .text, right? Now let's take a look at that file, right? So if I look at this file, you'll notice new file.txt is owned by Joe, which is normal. That's what should happen, right? All new files that you create will be owned by you and your group. This is an undeniable fact in Linux. That's how it works, okay? Unless you SGID the folder above. So let me show you, okay? First, I'm going to remove new file.txt. All right, now I'm going to add that SGID bit. So sudo chmod. Well, actually, I don't even need sudo. Well, I might need sudo now because I don't own it. Well, no, maybe not. I don't know if I do. Let's try it. chmod. And then we'll do G plus S, right? Of course, you could also do 2 and then 777 or 2 whatever permissions you want. But I'm going to do G plus S and then a dot for the current directory that I'm in, okay? And I can't do it. I thought so. Sudo it is. Okay, so lsattr al, see it? Okay, now you can see I have the SGID bit on that directory, right? Now let's make a file. So let's do touch, new file.txt, and let's take a look at what happens. Check that out. Now, the group that owns that file is test. Even though I'm still Joe and my group is still Joe, the test group is what owns the file, which is the group that matches the folder above. Why does that work? Well, if you think about what SetGID does when you execute a file that owns it, it basically runs the file as the privilege that the user, as the privilege of the owner of the file, right? And in this case, it'd be the group owner because it's SetGID. Well, in the same vein, right, when you make a file in the folder, it basically makes it with the same privilege as the owner, group owner of the file, right? So it's sort of like that. They're sort of related in that way. There's a relationship there, is what I'm trying to say. Anyway, the point is that is a very convenient way to make sure all the files underneath a folder are owned by the same group. Why is this important? What if you have a shared folder and you want everyone in the folder to be able to read and write to that particular file, or you want them to be able to have some sort of manipulative permissions upon that file, maybe execute, generally no. Maybe you want them to read or write the file. Instead of having where everybody has just a dumping ground where they put their stuff in and certain people can't read each other's stuff, maybe you want some level of collaboration in that directory. Well, if you want that, having them all have a shared group makes that possible, because now if everybody in that particular directory who has access to that directory is a member of that group, then all of a sudden all of these people can have this set of collaborative permissions in the group permissions on the file. And then access control lists can be used to further set up default permissions on files in the group. So basically when you create a file or a folder within the group, you can set it so that all the files come with read privileges for the group, or write privileges for the group, or whatever you want. And so that makes it possible to create an SFTP folder, for instance, where users have a very interesting way to share things without compromising the security of your system by giving everyone privilege, which is silly. So that is the power of the SGID bit, and it is a very, very, very nice bit, and I like that bit a lot, and I use it very frequently when I'm creating shared directories. So moving on, we also have the sticky bit. The sticky bit you can think of as the great defender. Oh, did I cover? Yeah, I did. I covered that. Okay, so, and obviously a capital S, you probably are aware of this now, means no execute, right? So if there's a capital S here, no execute privilege, right? I don't probably need to demonstrate that. Okay, so the sticky bit, you can think of it as the great defender, right? It is the defensive bit, basically. The sticky bit is represented by the character T in the other column, or the world column, or the everyone column, however you want to refer to it. It is the final 3 characters here. That X will become a lowercase t. In the case of no execute, it will become a capital T. Okay. It has the octal representation of 1, so it is the same as the execute privilege in its representation anyway. So the first bit would be 1. And it mainly is used to protect files within a directory. So if a directory has the sticky bit set, a file can be deleted only by the owner of the file, the owner of the directory, or by root, but not by anybody else. This is also useful for publicly accessible directories like temp, or shared directories such as an SFTP folder. Why is that important? Well, think about it. Let's say I create a file in a directory, and I want to make sure that only I can delete it. But I do want other people to be able to contribute to it. Maybe I want them to be able to add a line on occasion, or, you know, manipulate it in some kind of way. But I don't want them to necessarily be able to delete the file. Now, you might be thinking, well, couldn't they just go into the file and blank it out? Yes, they could. I understand that, but stay with me, okay? Let's say you want them to be able to write to the file, but for whatever reason you don't want them to be able to delete the file. Well, then you can add the sticky bit on the directory above, and that means that all files within the directory are only going to be able to be deleted by the person who made them, or by the group owner, or by root. So effectively, it is another way to manipulate files such that you can protect them from being deleted by rogue users or other people or whatever. And as the, you know, as I said in the example, it's also, you know, nice in directories like temp. So if you want to put a file in temp and you want to make sure other users can't go in there and mess with it or delete it for whatever reason, you know, maybe you need it there for something, you know, you can do that, and then they can't delete it unless they log in as root, if they have root access. So to show you the sticky bit, basically that is a chown, or actually let's do sudo. I think at this point I need chown because I'm not the owner of the directory above anymore. Or chmod, sorry, chmod. And then we'll do O plus T, okay? And then our new file, .text maybe? Oh, actually I should have just done yeah, let's do O plus T like that. Okay, so this one we'll do ls tag AL like that, okay? And now here you can see I have a T right here, right? And here's an example of it not having the execute permissions because I put it on that new file.txt by mistake. So what does the sticky bit do on a file? Pretty sure actually nothing is the answer there. I don't think it actually has an effect on standard files to my knowledge. At all. Yeah, I don't think it actually does anything on a normal file. It's generally just for folders. So yeah, that is that's what the sticky bit looks like basically. So you have the little t if it's there, and you have the big T if it's not there. And you can see here, right? I am in this folder. Let's see, do I have, okay, so let's sudo chown, we'll do test, and then new file. Okay, and then we'll even take the sticky bit away from new file, so let's do -t and then new file, that, okay. And then we'll do an ls hack al. All right, now you can see that I no longer own new file. I'm not a member of its group, I don't think. Let's do groups. No, so I only have myself and sudo. Okay, so I'm not a member of this group. And so what that means is I should no longer be able to delete that file. Even if I do a yes here, operation not permitted. Okay, so I can no longer delete that file. But if I go into that file, right, I can, or at least I should be able to. Oh no, it does actually give it read only, doesn't it? File.txt. Yeah, so you can't, I can't actually write to that file. Let's see why. Why can't I write to that file? Oh, that's why. Yep, so chmod O plus W new file.txt. Let's say please. Now if I go into new file.txt, I should be able to write some stuff up there. And now you can see that I can write, but I cannot remove it. Right? No dice. Okay? So, and this is despite the fact that I can read and write to it. And if I remove the sticky bit, gotta say please, O minus T dot. Okay? If I remove the sticky bit from the folder above and I do rm new file, gone. So you can see the effect right there in real time. Okay, so there is one more concept I want to talk about before I go, and that is how to make something truly read-only. What's the difference, okay, between read-only and removing the write privilege? So if I remove the write privilege from a file, there are things on the system that can still write to it. Anything owned by root could still do it, right? If I was a root account, I can still write to anything I want, right? So for instance, if I make a file, touch new file.txt, right, and I do chmod, we'll do 444, yeah, and then new file.txt, right? And if I look at this, okay, nobody has write privileges to this file. If I open this file by new file.txt, okay, and I go in here, warning, changing read-only file. Nope. Nope, not a thing, right? So if I cat that file, you can see nothing has been written, completely blank. But if I sudo up and become root, right, and then I do by new file.txt, which I know that, you know, sudo edit, I know. I'm the only user on this file system. I'm not worried about it. But if I do that, right, actually, you can see if I cat new file.txt, I was able to write to it. Even though it said it was read-only, I was still able to write to it. Because root can break through any permission. So how can I make that truly read-only? Well, that is where our lovely little command called chattr comes into play, along with something called immutability. Immutability, or making something immutable, is effectively the same as checking the read-only box in a Windows system, right? It is basically how you make a system truly read-only. And this has some very interesting applications. First and foremost, you can protect a file. So if you have like automation that's constantly knocking a file over and you don't know where it's coming from and it's driving you crazy, you can temporarily make that stop by making it immutable. And by temporarily, I mean hopefully you go and reverse it and fix the real problem eventually, because you know you don't want to just have a whole bunch of immutable files on your system. That's going to get messy. But one thing to note is if a file is immutable, you're not going to see it here, right? This will give you no indication of immutability. Okay, so let's make a file immutable real quick. chattr plus I, right? You can see I've done this on this system before. New file.txt. All right. Actually, got to sudo up. Okay, so only root can change that. Okay, so now if I lsattr it, you'll notice that there's no difference. It does not look any different than it did 5 seconds ago, right? So let's see if we can do something to it. So let's chown it, or chmod it, and let's add some write privileges to it. We'll make it a 644, and I'm the owner, so I should be able to write to it, right? So let's go up. And you'll also notice I can't change permissions now at all. Can't do anything to it. Can't do a darn thing. Nothing. Completely off limits. So let's test. Let's see how to determine if something is immutable. Let's take a look at C8. So to tell if something is immutable, we'll use the command lsattr. Okay? lsattr, and then you can provide new file, or you can do just lsattr and then a dot to see everything, I think. But you'll see here we have an I. Okay? And this I is what means it's immutable, right? So if I do a chattr minus I, right, like this, that is how you remove immutability. And of course you need root privileges to do it, okay? So now if I lsattr, you'll see the I is gone, okay? If you want to know more about it, I think you can do man chattr. And then if we look down here, you can see all the different characters and assignments and attributes and what they do, basically. And there it is. That is our favorite immutable flag there. The I attribute cannot be modified, cannot be deleted, renamed, no link can be created to this file, most of the file's metadata cannot be modified, and the file cannot be opened in write mode. Only super user or process possessing this has the capability to clear this attribute, right? So it is a very powerful flag that basically means you can't touch my file. Don't touch my file, right? So where can that be applied? Well, like I said, you can use it to thwart automation if it's bugging you. You can use it to prevent a file from being updated if there's something that constantly updates the file. You know, if you have a rogue cron job that you're trying to debug or something and it keeps messing up something, you know, if you have a setting that keeps going back or reverting for some reason, you can use it for those purposes. I don't like using immutability for those purposes, especially not on a permanent basis, because it's really the wrong way to do it. The right way to do it is to track down what's actually causing the problem and fix it. But there is one application that I will go over in another video that is very interesting, and that is file system mounts. So if you're not a Linux aficionado, file system mounts are basically a way of saying, let's take a drive, a remote file system, like a file system on another server, and let's mount it to our system so that we can access and manipulate it, right? Now the problem is, what if that file system goes unmounted for some reason? Like, let's say your computer boots up and there's supposed to be a file system on another server that's supposed to be there, but your network card wasn't up, or your network connection was broken for whatever reason. Maybe you have a network failure, or maybe that server was offline and that file system did not mount. And what if your system was writing logs or outputting data to that particular file system? Okay, what happens when that file system goes unmounted? Well, now it's writing that data to the underlying hard drive on the actual server, okay? So it's taking up storage on your actual server because it's still gonna write to that location, and that location still very much exists because when it's not mounted, it's just a normal folder, right? It's just writing to your root volume or whatever it was attached to instead of the mounted file system. So what happens then is all this data starts getting dumped to your normal hard drive. But then later, let's say that file system remounts and you've got all this hard drive, this stuff that's still on your hard drive, but now that file system is mounted because you've rebooted or whatever, and you know, now it's mounted again and it's fine. But over time, you know, you're using your computer and you realize, hey, I'm kind of short on storage. What's going on? Everything looks fine. Everything's mounted fine. Everything looks good. You can't figure out where the differential is. Well, it's under that mount point. And once something is mounted, everything below that point becomes inaccessible, okay? It's like it doesn't exist. So it's very hard to figure out, oh God, something's actually stuck underneath that mount point and I can't get to it. And the only way to get to it is to unmount it and then delete whatever's there or move it, you know, preferably move it if it was important. So how can I avoid that? Well, make your mount point immutable. Believe it or not, it's wonderful. It works perfectly. You make your directory immutable, and what it means is that nothing can write to that directory unless something is mounted there. Then you can write there, and it solves the problem. So that's food for thought for anybody who is interested in making remote file systems that they can share, or mounting a file system or whatever to a critical system. If you're offloading logs to like a central server somewhere and you're not using something like Splunk, but you're just old schooling it onto like a shared drive or something, or maybe you've got a like a Nextcloud server with and you've got a mount on a like file storage system for your data drive. That's actually a very pertinent use case, because that's how I do it, right? Well, I made that mount point immutable. So if that mount point goes away, Nextcloud's not going to dump stuff into that point. It's just going to not be able to do anything. It's not going to work, right? Until I get that fixed. So, yeah, food for thought. Anyway, this concludes the video. I think at this point, sort of reached a stopping point here. Hopefully this was very educational for anybody who was watching. I do sincerely hope it helped out. I know my videos tend to run kind of long, but I like deep dives. What can I say? Yeah. See you guys in the next video.